All right, so for 25, it's kind of more of the same. We're given an equation, y is equal to, oops, let me see what that is. 2 sine, let me bring that down here, 2 sine of, oh my goodness, x times pi minus y. And then they want us to find the slope at the point given to us. Actually, they want us to write the normal and the tangent line at the point 1, 0. So what I'm going to do is, you guys, you normally can't, this one you can on your graphing calculator, but I'm going to, Mr. Adams is just going to do it on his computer here, because this one does like ellipses and circles, where your graphing calculator, you got to jump through some hoops to get that done. Just so you see it, it doesn't ask us to graph it, so... All right, so now if you look at that, that's kind of a crazy line. And what they want us to do, and look, I don't know if you guys realize this, they want us to find the slope of the tangent line right here at 1, 0, which is right here. It's not quite vertical, but you could see that it's a very steep slope, and then the tangent line will be perpendicular to that. Okay, so that's what the graph looks like. So the first thing we need to do is we need to differentiate this. So to differentiate this, this is a little bit more challenging, because we need to take the derivative of this. So if I take the derivative of y, it's just dy dx, right? And then we set that equal to, now this is where it gets complicated. We have 2 sine of all this stuff. So the derivative of 2 sine is 2. The 2 comes to the front, okay? I'm going to change my marker. This one's running out of ink. The 2 comes to the front. And what is the derivative of sine? Cosine, right? And then the stuff on the inside kind of stays the same. But then we have to tack on the derivative of the stuff on the inside. So x pi is the same as pi x. In other words, pi is a number, pi is a coefficient. That gets tossed to the front. So, like, what would be the derivative of 3x? It'd just be 3, right? Well, what's the derivative of pi x?
Pi.
Just pi.
So
All right.
pi minus 1.
So it's pi minus 1 dy dx, right? Because whenever we take the derivative of y, we tack on the dy dx. So I'm just going to say minus dy dx. Does that make sense, you guys?
Yeah.
All right. So now from here, it's just we're just going to solve for the dy dx. It's a little challenging though, because I'm going to have to do some. I have to distribute some stuff through the parentheses. I don't really like it. But what I could do is that I notice, well, let me show you what I mean. I notice that I need both dy dx's on the same side of the equal sign. I'm trying to think of the easiest way to do this. Like, if I move this over to the other side, I'm going to have to do some math. If I distribute this through, I'm going to have to do some math. So there is no easy way. So basically, I have 2 pi cosine of x pi minus 1 minus 2 cosine of x pi minus y, and then that has the dy dx tacked on. Yes.
Why do you have 2 pi cosine on the first one?
Because I'm multiplying this by pi. And pi is technically a number, so I just tossed it to the front. And so this one's negative dy dx, so I put the negative in the front and then just tacked on the dy dx on the other side. So now what I need to do is I need to add this term to both sides. So I've got 2 cosine of x pi minus y dy dx plus this original dy dx and all that's equal to 2 pi cosine of x pi minus y. You guys with me so far?
Bless you.
Bless you. So now if I factor out the dy dx, I've got dy dx times 2 cosine of, I'm going to write pi x, it doesn't matter, minus y plus 1 equals 2 pi cosine of x pi over y, all that stuff, right? So now what do?
Divide by.
Divide by both sides. So if I got to divide by all this stuff, right? So dy dx is then equal to the numerator, which is 2 pi cosine of x times pi minus y all over 2 cosine of x times pi minus y plus 1. That's it. But now I've got to evaluate it at x equals 1, y equals 0, right? From way up at the beginning of the problem. Okay? What do you notice about the... oh, well, I have to be careful. I almost canceled out the 2's. Can I do that?
No, because
No.
it's. Yeah.
No, I can't. So now I've got dy dx is going to equal 2 times pi times cosine of 1 pi minus 0 all over 2 cosine of 1 pi minus 0 plus 1. So I have, what's cosine of pi? Does anybody remember?
0. 1.
Well, let me, if we think in our heads, the unit circle, remember that it's cos, comma, sine. Okay? Now what is pi? Pi is right here, right? We all see that I'm taking cosine of pi and cosine of pi, right?
Yeah.
Alright, so this point right here is negative 1 comma 0. So what's cosine of pi?
Negative.
Negative 1 times 2 pi is negative 2 pi. You guys see that? This whole thing becomes negative 1, right? You guys with me on that?
Yeah.
Alright, now this whole thing also becomes negative 1. So I've got negative 2 plus 1, which is...
Negative pi.
no. How would you get pi? Yeah, well, yeah, at the end. But don't jump ahead of me. This is 2 times negative 1 is...
Negative 2.
plus 1
1.
is 1. So the final answer is negative 2 pi. For the...
Wait.
for the slope.
Isn't it negative 2 pi over negative 1? And then.
Oh, is it negative 1?
Yeah.
Yes, you're correct. It's negative 1. Sorry. So this would be positive 2 pi. Now I skipped a step. Is that throwing anybody off? If it is, let me know. I'll explain it to you. See, we've got 1 times pi, which is pi, minus 0 is pi. So cosine of pi based on the unit circle is negative 1, right? It's negative 1. So then this whole term is negative 1. Negative 1 times 2 pi is negative 2 pi. Then over here I've got 2 times cosine of pi, which is negative 1. So we've got 2 times negative 1 is negative 2 plus 1 is negative 1. The negatives cancel, and I've got 2 pi over 1, or just 2 pi. So here's the beauty of this thing. What were we supposed to do?
and normal.
Find the tangent and normal. So now that we've got the slope, we've got to write the tangent and normal line. So to write the tangent line, I need the slope, which is 2 pi, and I need the point 1, comma 0. And I got to plug it in. So I'm going to say y is equal to m times x minus x sub 1 plus y sub 1, which means y is equal to 2 pi times the quantity x minus 1 times, or plus 0, right? Because this is x sub 1, y sub 1. You guys with me so far? So y equals 2 pi times x minus 2 pi. What's that?
The line. There's a tangent line.
That's the tangent line. So remember, about a half hour ago, I graphed the line itself, and I want to see if this tangent line intersects at the point that we need it to. So 2 pi times x minus 2 pi.
Yes.
Does it?
Yes.
It certainly does. Now we got to do the tangent line. We're not done yet. All right. So for the tangent line, I'm sorry, we got to do the normal line. Oh, long day. So now for the normal line, what do I have to do differently?
You have to use the negative reciprocal for the slope.
So now I'm going to say y is equal to negative 1 over 2 pi times x minus 1 plus 0. So I've got negative 1, 2 pi x plus 1 over 2 pi. Shall we graph that and see?
Sure.
Alright, so let's see. We've got y minus 1 divided by 2 pi x plus 1 divided by 2 pi. Oh, I need an equal sign, not a minus sign.
Yeah.
Well, what do you guys think?
1-0. Represent.
Okay, so that was problem number 25.
Thank you.
You're welcome.